Hi everyone, we're here today. Everybody's pleased to be here for another JVMLS. I had to miss the last few, so I'm really glad to be back in this company and in this group. This is the best conference that I ever get to attend, so it's really good to be here again. And today, going to be talking about ConstantDynamic, oxymoron or powerful new tool. And you're getting a lot for your money today because you're getting not only me, one of the IBM developers working on Eclipse OpenJ9, but you also get Paul here today, who's one of the consulting members of Oracle's technical staff. So you get both of us. So always we have to start with these safe harbor slides that say don't base your product decisions on what we're saying today, right? Lawyers. So time to start by defining some terms. All right, our title says oxymoron, but if you're not familiar with that, it's a combination of contradictory or incongruous words, such as cruel kindness. And then we have the term constant, which is something invariable or unchanging, such as a number that's fixed, a mathematical constant, things that aren't going to change. And then we have dynamic, which is marked by usually continuous and productive activity or change. Right? So at this point, oxymoron or productive new tool. You're going to get to choose, and hopefully we persuade you throughout the course of this talk that it's a useful tool and not just a misnamed feature. All right, so to really get into this, to understand what ConstantDynamic is, or as I'm going to keep referring to it as Condi throughout this talk, just out of habit, we have to understand Invokedynamic. And I probably don't need to do the refresher on Invokedynamic in this particular audience, but we'll run through it because it makes the rest of the talk work a little easier. So here I've got an example of an Invokedynamic. We've got the Invokedynamic bytecode. It points at some constant pool entry. That constant pool entry points into the Bootstrap methods, where I have some method that I'm going to run to control the linkage. It can take some static arguments that get passed into that Bootstrap. All right, so there's a bunch of parts here, and what happens? Well, the first time I go to run that Invokedynamic, it's unresolved, of course, and so I get to take a nice little tour through some user-specified code. Right? This is a big change in Java 7 for the VM, where rather than having all the linkage decisions decided by the JVM, we opened it up and put the user in control of what was going to be linked here. And that Bootstrap method does a bunch of work. It figures out what it wants you to call at that Invokedynamic, and it gives you back a call side object, which is bound to a method handle. And then that Invokedynamic is permanently linked to that call site, and you've got some objects here to be able to return your constant, right? Or to return whatever you want to have happen there. All right, so that's Invokedynamic. Why could you want anything more? Well, in Java 7, when we did Invokedynamic, a lot of the focus at that time was on dynamic languages. And one of the major problems dynamic languages had was calls. In order to do calls, you frequently fell into reflective code. And to make that call, you had to box up your arguments. You had to go through reflection, you had to unbox all your arguments, and you usually ended up with a lot of code at any given call site that was doing a bunch of things that didn't matter, not really in terms of what you wanted. And so we did Invokedynamic to be able to put that code out of line and let the JIT see all the way through your call sequence and give you some really good performance. And now doing that, putting the user in control of linkage, really opened the door to a lot of really cool things in the JVM. We saw it used by languages like JRuby. We saw it used in Nashorn. We've seen it used by Java for things like the Lambda Meta Factory. It's really been a renaissance of allowing different and more interesting things to happen at call sites. And it's been a big performance improvement. But we also recognized back at the time that we did this that there's a certain duality between bootstrapped constants and bootstrapped calls. We can implement either in terms of the other. So if you've done a lot of work with Invokedynamic at this point, you've probably already written bootstraps that basically return constants. But it's also possible to go the other way. We had a proposal back then as part of the expert group that said, look, let's do bootstrapped literals or bootstrapped constants first. And in that case, what you'd do is you'd return, your constant would be the call site, and then you'd just call through it. So you can do both. They have different levels of overhead of simulation costs. So if I really want to return a constant with Indy, what do I have to do? So let's start by looking at this slide, taking it from the bottom actually, and we'll work our way up. So I want to return a constant. So I need to wrap that in some kind of method handle. Maybe that's just a bound method handle. Maybe that's calling some other kind of method that returns my constant. But I've got at least one wrapper object to get to my constant. And I've got a bunch of invocation overhead, at least until the JIT comes along and cleans it up. And then, because of the way that Bootstrap methods work for Indy, I also have to wrap this in a call site object. So I'm on my second wrapper object just to return my constant. And then, additionally, my Bootstrap method has to do a bunch of work. Right? This is the user-supplied logic that figures out what the constant should be, but it also has to do some level of interning to make sure you always get back that same constant. With Indy, your Bootstrap method might be invoked more times than you would expect just by reading the bytecode, and I'll get into why that is a little bit later on. So we see there's a fair bit of overhead in getting to a constant using Indy. So what does Condy look like? Well, it looks an awful lot like Indy. This is an example using LDC of a constant dynamic, and this is saying I'm going to use Bootstrap method 0, and I'm going to, the name of my constant is Z in this particular case, and it's going to return a class. And so, it looks exactly like the Indy did. It's unresolved the first time we use it. We call in to link it and run the user-supplied code, and out of this we get some constant. In my case, it's boolean.class, which is a primitive class, which you can't normally encode in the constant pool. And then my LDC is linked to that permanently. So we've opened up the door to users being able to put anything they want in the constant pool. Okay? So that Condy, as I said, looks an awful lot like Indy, but there's still some differences here. So on this slide, I'm showing Bootstrap methods for both an Indy and a Condy. The top one is Condy, the bottom one is Indy, and they all start with the same options. They all start with a lookup, right? You need some option or something to be able to use a context to be able to do lookups of methods or whatever you need for the particular caller. They all take a name, which is passed as the string, and then we start to see where they differ. The Condy one takes a class, and that's the class that describes the type of the constant you're going to return. The Indy takes a method type, which describes the type of your call site that it has to be called under, and then the return values differ. Indy, it must be a call site, and Condy, it's whatever your constant happens to be. In my example here, it's a class. So to do a constant with Condy, I've got a lot less overhead. I don't have a call site, and I don't have a method handle. I'm linked directly to the constant I want. And this is really cool because it means that Condys can be used anywhere that loadable constants can be used in the VM. So you can use them in LDC expressions. You can also use them as static arguments to other Bootstrap methods. So I can have a chain of Condys that are all chained together based on things that are looked up at runtime. It means that I can pass runtime values into other Bootstrap methods, which is a pretty cool new tool. And then I had mentioned earlier that with Indy, your Bootstrap method might be invoked even more times than you were expecting. And that's because Indy, each instruction has its own linkage state. Indy's unique in terms of bytecode instructions that way, or constant pool entries, in that it's the instruction that has the linkage state, not the constant pool entry. With Condy, we've moved that back to the constant pool entry so that there's one constant that's shared across anybody who's using it. All right, so what does that do for us? Well, first thing it does for us is it says we can put all kinds of things that are constant into the constant pool, even if we couldn't before. So we can put null in the constant pool. We can put enum constants in. We can put primitive type mirrors. So the example I showed earlier used boolean.class, but any of those primitive type classes that you want, you can put in the constant pool now. You can put var handles there. So what this does, though, is it means that the ability to put constants in is no longer up to the VM. It's been put into your hands or into the language hands. And with that power comes great responsibility. We'll talk a little bit about some of the things that can go wrong with putting constants or non-constants into the constant pool later. And now, your Bootstrap methods that want to talk about primitive types can use Condi to do that. So you can actually be passing primitive classes around through the constant pool without having to resort to string encodings. And JDK 11 says, look, there's a bunch of patterns we recognize that are going to be really common that most people are going to want to use. So let's expose a set of Bootstrap methods that anybody can use. So this is a little bit of an eye chart. Don't expect anybody to read it. But if you're interested in the details, take a look at the class Java lang invoke constant bootstraps. There's bootstraps there for a lot of the common use cases that we can see or that have been shown from the prototyping efforts that have been done with JDK 11 so far. So things like null constant, primitive class, enum constants, being able to get final fields, being able to get var handles, and being able to invoke other method handles. So there's a lot of really cool stuff here. Do check it out. All right, but whenever we give you a new tool, we generally try to give some form of guidance on when and how to use it, on some of the interesting things to be doing with it. And so with Condi, the first piece of guidance we give is try and use the constant bootstraps that the JDK has already provided. If you need primitive types, use the one to get a primitive class. If you need null, use the one to get null. The reason for this is, you don't want to duplicate code if you don't have to, and the VM and the rest of the runtime has a common hook to look at and to be able to give you better performance. If everybody writes their own versions of this, it's very hard to do intelligent things in the runtime for them. All right, now, if one of those constant bootstraps doesn't help you or doesn't give you the thing that you need to think about what you're going to do when you write your bootstrap. And it's important to make sure that your bootstraps are idempotent. So idempotent means that it doesn't matter when or how many times your bootstrap gets called. As long as you pass it the same arguments, you should get the same result. And your bootstrap method is likely to get invoked a lot more often than you were expecting. And the reason for that is resolution is allowed to race. So if you have two threads and they both try to execute the same method that has a Condi in it, they're going to race. You might invoke that bootstrap method twice. This is already the behavior we see with Indy. One of those invocations is going to win and the other is going to be discarded. So if the correctness of your code depends on how often your bootstrap method got invoked, you already have bugs. And that resolution race doesn't have to be just within a single method. Right? I said earlier you can use Condis in a lot of different ways, not only as arguments to LDC, but you can also use them as other static arguments to bootstrap methods. And so you might have two threads that are running unrelated code that happen to reference the same constant pool entry, and you can get races there as well. And this again comes back to the shared resolution status for Condis versus Indies. So the other piece of guidance we give is if you're going to use Condi, you have a number of arguments that you get passed. It's the standard metadata, right? There's the lookup argument, there's a name, and then there's a class that describes your constant. That name, it's perfectly valid to use it as an argument to describe what you want. That's what the top LDC does here. It says, hey, look, I want Z, or in this case, the Boolean primitive class. And that's what the top bootstrap does. In the second case, where I've named the constant pi, it uses the second bootstrap method, which I haven't renumbered on this slide. Oops. And that bootstrap method doesn't need the name. It doesn't need any context to be able to return pi to you. It's just a known thing, right? But if you use that name field, you can give some semantic context to your code. It makes it easier for anybody reading the bytecode to understand what you expected to happen here. Okay, so that's a couple of pieces of advice on how to use Condi. What are some of the pitfalls you can run into with it? The first one is you can't use Condi, the same Condi as an argument to its own BSM. You're not allowed to do any direct cycles. If there's a direct cycle, you're going to end up with a Stack Overflow. Now, having said that, you can do indirect cycles. So if you have a constant dynamic and during its bootstrap method, you happen to invoke something else that will trigger the re-resolution of that Condi, that's okay. In typical cases, you're going to still Stack Overflow unless you've done something using external state to avoid that. So in most cases, if you have cycles, expect a Stack Overflow. The other possible pitfall with Condi is that once you put something into a constant pool, it then has the same life cycle as the class. So if you've created some kind of constant that holds on to a class from another class loader, you've now tied those two class loaders together. I can't get rid of the second one until the first one gets unloaded. Right? The more this gets used, the more likely we're going to run into people being surprised by the equivalent of class loader leaks in app servers. So be thinking about the constants you put into constant pools, be thinking about their life cycles, and also their class loaders. And really, Condi resolution is similar to class initialization in a lot of ways. If there's pitfalls or deadlocks that you can run into there, you can run into a lot of the same kinds of problems with Condi, with the limitation that there's no direct cycle, so that makes life a little bit easier. All right, so Condi, great new tool. There's some pitfalls and practices we've mentioned. So now let's start looking at some of the use cases for Condi. We'll start by talking about some of the simple use cases and then transition into some of the more complex ones. Who in the room has written code like this at some point in time? Way fewer hands than I'm expecting. Come on, I would have expected everybody has run into some kind of initialization problem. All right, yes, here we go. This is code I ripped out of OpenJ9, just in one particular case where we had a problem with initializing something too early in VM startup, and so I had to push it off into a static field in a helper class. The reason we typically do this is either bootstrap or initialization problems, or to be able to rely on the VM to manage the creation and lifecycle of that particular field. But this forces you to write these garbage classes, these helper and holder classes. With Condi, there's a lot of cool options to be able to get this same kind of delayed initialization without having to write the class. So you can use the constant pool to do the things that it's good at, to hold on to your constant, to be able to give you that delayed initialization. And if you're interested in ways that this shows up in the language, or could show up in the language, Brian will be pushing on some of this immediately after this talk, or presenting on. So another area where we have grounds for optimization out of Condi is var handles. So var handles were introduced in Java 9 as a safer form of unsafe, at least for a lot of the practices where you needed to read or write fields. And the best practice at the time said put them in static finals. It saves recreating the var handles over and over again, and it gives the JIT something to root its optimizations on. But there are cases where you can't do that, or the static finals force things to be loaded all the time that you didn't need all the time, or some JITs don't always trust all your final fields, so you've lost some optimization opportunities. Now with the ConstantBootstraps var handle helpers, you can push these into the constant pool, and you get the better optimization. You only create them when you need them. They're closer to the paths that you want. And JITs do trust constant pools because they're known not to be modifiable. Okay. So at this point, I'm going to switch to Paul's deck. if I can find my...
Okay, thanks, Dan. Two speakers from two different companies. You get two safe harbor statements. Aren't you lucky? Okay, so I'm going to start out with a little quiz. Quiz in a quiz. So Bootstrap methods are commonly declared as static methods. I think everyone is very familiar with that. Dan showed the bytecode for what an indie would look like and what a condy would look like. Here's what an indie BSM might look like. It returns a call site, takes a method type as a parameter, and a condy can return its own constant and take a class. So just before I get on to the real question, I want to ask another question. How can we merge those two condy, the indie and condy BSM together? Is that actually possible? So I can have one Bootstrap method for a condy and an indie? Anybody? Yeah, I knew Remy would be there. So we can merge it together, and we can just replace the third parameter with object if we want to. It's kind of yucky. I don't expect people to do that, but it gives you an understanding of how Bootstrap methods are invoked, essentially. Going forward, we could do better than that. What happens if we could replace that with a better top type, like something like type descriptor? That gets into a bit of what Brian will talk about with his API. And bytecode, utility, things like ASM, I think, could use this type of thing as well. But back to the real question was, is there another way to invoke Bootstrap methods that are not static methods? Can we do another thing instead? What have we got? Availability. Anyone know? Maybe except Remy? No, okay. Well, we can use constructors if we want to as well. I was surprised when I first encountered this, and I think it surprised a bunch of us. We can have a method handle to a constructor instead, because it doesn't take a receiver. You've got all the information available. You can plug into the constant pool and get that executed. Now, this might not be much use if you're using indie, because all you can do is extend from call site. So there's little opportunities here. But it might be more widely applicable in ConstantDynamic. So what I thought was a more esoteric area or something might actually be more usable to people. It's not as usable as it can be because you've got the lookup name and type class. So you can't just pick out anything you want to use. You might have to modify something, but we'll get to that later on. Okay, so I'm going to talk a bit about future stuff. Of course, when we talk about future, we're not exactly saying it when it's going to happen. I like Ron's answer to that question, 6 months after it's ready. Okay, so let's talk about enhancements to Bootstrap methods. One thing we found, especially Brian found when designing his work, he'll talk about later, is that the Bootstrap methods have to take these 3 parameters at the beginning. There are ways they don't have to declare them, but they'll get pushed onto the stack when you invoke the method, the lookup, name, and type, the method type or class. In some contexts, that metadata is not actually needed. And so it can be a bit of a pain to have these lying around in some sense. So if you have existing methods you want to reuse, you'll have to wrap them explicitly, or you can use one of the methods in ConstantBootstraps that Dan referred to. So in this case, we can use ConstantBootstraps invoke to invoke our own method if we want to do that. In fact, this is quite an important concept, so it's actually worth digging into a little bit more deeper. So we have this method here. Here's a Java doc. I just wanted to show you it, more to get the point across that this is a Bootstrap method that takes a bunch of args, but before that it takes a method handle. And what it will do is you invoke this, and then it will invoke your method handle with the static arguments you passed into it. And it will not pass the lookup, name, and type into it. And here's a canonical example we often talk about. So if you've got ConstantBootstraps invoke, you're going to talk about, plus list of method handle, plus static arguments, you can have yourself return a constant list that contains constants in it. And that's actually quite nice. So it's sort of like an expression tree in the constant pool, if you like. But that requires a bit of ceremony to express that. So one thing we've been looking at is how can we sort of drop these metadata arguments. So in Java, in JDK 11, what we did was we sort of reserved space to make this possible in the future. And so we constrained ConstantDynamic Bootstrap methods in ways that indies aren't constrained. So the first parameter type of your constant dynamic bootstrap method must be of lookup. Other than that, any invocation is the same. And that reserves a space later on for us to decide to do different sort of invocation modes with condi than to indie. So we reserve that space and wondering, well, is this a good idea or not? Let's just do this in case it is a good idea, so we don't get people coding in the same way to indie, and then we can't make this decision later on. So in Java 12, we have a point solution for this. It's WebRev out there on the existing stuff in the Amber repo, which allows you to say, if the first parameter of that bootstrap method is not lookup, then invoke the bootstrap method without the lookup name and type. That's simple, a very simple point fix. Other than that, it's the same types of invocation behavior. And if you circle back to the using constructor method handles, that incidentally makes it easier to use constructors. So if you've got an existing class out there that you can use directly, you can now use a constructor method handle if you so wish. I just thought that was a nice sort of circle around. It might not be the right thing to do, but you can now sort of pick and choose from a lot of stuff. And as Dan said, that's a powerful opportunity which comes with some responsibility, I think. But there is a better way, a more cunning way from Mr. Rose over here. I say you can cut a little tail, put it on there, and it would be a baby weasel. It's so cunning. So in this case, instead of, what we're doing with this dropping is, back to what we referred to invoke, it's essentially invoke semantics, what we're saying here. This is what we want to really talk about. So invoke will take a BSM, accepting the actual BSM to be invoked without the arguments, the lookup name and type. That's it. So let's call this behavior invoke and specify it as if it was the constant bootstraps invoke without the additional CP ceremony around that. And declare invoke in the dropped name. And then we can specify that behavior using the name that we dropped beforehand, and that becomes something we can extend to other forms of invoke behavior if we so wish. I think John has ideas for multi-invoke type behaviors as well, where you have a bunch of method handles consuming some subsets of the arguments, and it goes through it all, invoking to return your constant at the end of it. And maybe other forms of bootstrap method invocation, not just related to constants in the future. So it's basically expression mode or expression tree mode behavior here. And you can imagine internally how this is implemented. You just got a master internal bootstrap method that just dispatches off the name to the appropriate behavior you have. And I think that's a nice way, rather than a point fix, of encoding this information. So this is just hot off the press. Feedback, please. And we think we're going to pursue that. Expect a commit in the Amber repo soon, John, related to this, I think. So that's a nice outcome, I think. So on to a second area we've been looking at, which is lazy resolution of bootstrap method arguments. So at the moment, bootstrap method is invoked. All the arguments have to be pre-resolved before you actually call the method. That's the only way you can do it. And any resolution error from that is propagated before you invoke. That's all it can do. You don't have any control over the sequencing of those arguments and the resolution of them, so you have poor error control or reporting on that. And that gets more interesting than the larger or the more arguments you actually have to process. So we need an API to do this, and we need one or both of the following to actually support this. So we need to resolve arguments on demand, and including after the bootstrap method returns. Why should we just limit it to the scope of the bootstrap method execution? Maybe the constant you return holds something that is itself not yet resolved until you actually call on it and operate on the constant itself. So we can propagate the control of resolution beyond the bootstrap method invocation itself. You can see a prototype of this. It's called Bootstrap call info in the condi folding branch of the Amber repo. But we can take this further. What we can also do is access an argument in, say, its nominal form. There's information in the constant pool. Why can't we get access to that information directly and poke around in it directly without causing a resolution of that information? And this is where Brian will get to talk about this in great detail. in his work, but can we merge these two things together? We are thinking we could put Bootstrap call info in JDK 11, but we held back, and I think there's good reasons for actually holding back on that, because we weren't quite ready, and there's better synergy potentially with these two things going forward. So here's an example, hot off the, this is not exactly what's in the source code, this may be what more like what we want, but it's still work in progress. So we can have a new form of Bootstrap method invocation. So it accepts a lookup, and it accepts a Bootstrap call info, and that's it. And so in this mode, we're essentially got this container saying, here's all my arguments. I haven't resolved them yet. At least I haven't. Someone else might have done, but I haven't. So it's kind of like a container for all the arguments we have, in this case an ind. We can get the invocation name and the type out from that, and we can get our first argument from there, which might result in a resolution error. Or we could ask if an argument has been resolved already, and if it is, we can get it without an error. Or we could actually get the argument, and if it hasn't been resolved, give me a default value instead, and so forth and so on. Or, example, give me a subset of give me a subset of resolved arguments, and so forth. So there's a lot of control over this, and you can imagine it's easier to control the errors that are produced, from this Bootstrap method based on resolution of these arguments. And there's potentially another way here, linking to the second point here, which Brian will get more into, is what if you want to get access to the nominal form? So we could choose to actually get a reference to a box, if you like, to stuff in the constant pool. In this case, call it constant desk. And it allows you to access in nominal form, so that won't result in a resolution error. But when you choose to resolve it with the lookup, that could result in a resolution error in there. So we can merge these two APIs together a little bit. It might even be possible to use that box directly in Bootstrap method arguments themselves. I'm not sure if this is actually viable or not. I think it gets more complicated when you replace that question mark with the actual type you want to use. That would be nicer, but I think that's actually even harder to do. I'm not sure. We would lose that information in the bytecode, I think, unless we tell Java-C to do something special. But that could be useful in some cases, and it's something we could almost certainly look at. So I think it's useful to summarize what I've just talked about here and on the various forms of invocation. It can get a little confusing. So in Java 11 today, there's no change in Invokedynamic at all in its invocation. And for ConstantDynamic, the first parameter must be a lookup. That's it. So what could we do in Java 12 and beyond? So we have a constant and Invokedynamic supporting lazy resolution, so that Bootstrap call info stuff I talked about can be applied to both Indy and to Condi. And we could explore parameters in sort of like calling it the box nominal form. So we can explore all that for both cases. And for ConstantDynamic, we can look at a new form which we call expression mode when the first parameter is not a lookup and the name declares behavior. And we have one so far, the invoke, ConstantBootstraps invoke, which effectively drops the argument. So that's it, what we're looking at now. So feedback on that. What are we missing? What are the problems with this? Dan, when I was going through the slides with Dan, where's Dan again? I don't know where he is. He's already picking out problems, which is good. So what can we do to leverage ConstantDynamic in our own platform? So as Dan mentioned with Invokedynamic, it's the instruction where the linkage occurs and the work occurs. And so when you got these method references here, string is empty, if you declare it more than once in there, you get two Invokedynamic instructions. Every time you invoke two Invokedynamics, and they produce two instances of the predicate. The Bootstrap method gets called twice, even though it's really referring to the same thing. Actually, we just fixed a bug related to identity of lambdas and method references and serialization of these things. We really shouldn't care about the identity of these things at all. They can refer to the same thing, but they don't at the moment. So it's called twice. What happens if we replace it with an LDC? You notice the translation here is very, very straightforward. We can place the indies with LDC, tweak what Bootstrap method we call, and then the Bootstrap method is only called once. Because we're loading a constant, we load it the first time, we hit the first predicate, And the second time, it returns the same instance. So if you're relying on identity of your lambdas, please don't. Just as a segue, I think there's been some very useful work, related work done to this. I'll get onto it in a moment. So just to summarize, we can use ConstantDynamic for method references and non-capturing lambdas. So Vincente modified Java-C in the Amber repo to support LDC instead of Invokedynamic for method references and non-capturing lambdas, because if they're capturing, they're not essentially constant. But related to this, I think related to the general push of being more efficient in the bytecode, there's some great work done by Google and Liam, who's sitting over there, to dedupe lambda expressions. So that was really cool work. And so here's an example of this. So in the main repo now, lambda expressions are now deduped. So I have two the same lambda expressions up above that are non-capturing. These will point to the same Invokedynamic bytecode now, and the same desugared method in your bytecode. And it will also work for non-capturing lambdas as well. So the synergy here is if we move over to the Amber repo and do that, the top two will be replaced by LDCs as well. So increasing efficiency in the bytecode. Nice work on Liam's side, and it's really it's complementary with the work done here as well to increase the efficiency. Okay, if you're really into efficiency, you'll notice there's smaller bytecode indexes as well. If we just go back, saving a few bytes. That's because the LDC is not a wide LDC, but maybe for larger class file bytes, that won't be so apparent. Okay, so future. I probably have about 3 minutes to decompress this. So probably condy is not the last word in constant pool entries, I think. We could go a bit further. It very much depends on what use cases might require these in the future. So it's very much thinking ahead of what they might be and whether these will actually be usable. And when there's a strong enough use case, then we may start looking at these more in detail, perhaps. But we have essentially groups, ordered sequences of embedded or reference constants. These are a bit like the static argument lists that you have in a BSM, but more general. So you could actually embed constant data in a group and hide it away from the main area of the constant pool. And you can overcome the size limitations that are currently present with static argument lists. And the other one is raw bytes, which probably doesn't resolve to a byte array because that will involve a copy, so we need an abstraction for that, whatever that might be. You can simulate that with base 64 encoding in strings if you want to, but that's a pretty yucky thing to do. What happens if you have bytes directly in the constant pool you can access? You can do all sorts of interesting things. That's bytes just a place to scribble data on. It doesn't have to be represented as bytes. Like you have a byte buffer that can be viewed as a primitive long byte buffer. So you could have primitive arrays directly embedded in. If you say we're serialized forms, do you want to serialize your own data into the bytecode and reserialize it out? Structures, perhaps Project Panama can, for structural overlays in your constant pool. I'm just ad-libbing here, but it's possible to do all these things. As I said, these things are to overcome certain size limitations in the constant pool, sort of sidestepping it, not having to do a massive restructure of a constant pool itself, but just pushing off to these to the side, and to potentially create alternative exotic stuff that we haven't thought about before, distinct from the main CP or constant pool, but in the class file bytes. So if you think you need use cases for these, you think these are useful, we'd be very interested in hearing feedback on this. And we probably will find use cases ourselves as we push on the new features in going forward. To summarize, so I think ConstantDynamic is quite a powerful new tool to its older sister, Invokedynamic. Very similar, but also quite different, and it'll be when JDK 11 goes mainstream, it'll be really interesting to see how others are going to use this in Scala, Clojure, Kotlin, other bytecode generating stuff. and see how we use this. I would argue that we're just scratching the surface of some of this area. And when we look at constants in general, we're really pushing hard on this and scratching the surface deeper. And I think with that power that we expose out, oops, I'm nearly done. That power that we expose out comes with some responsibility. And the question is how much responsibility we want to push on the users, or how much we should keep internal to us, because we don't trust people to shoot themselves in the foot. We shall see. Just to talk on the futures again, those future constant pool entries I briefly talked about, I think they require some strong attractors to actually push through, and that remains to be seen what they actually are at the moment. And with that, that's it. I think we have about 5 minutes for questions. Is that right?